Okay, here's just a quick refresher on adding fractions without any letters. Okay, so remember when you had, say, 1/3 plus, say, another third? When the denominators were the same, you would simply add the numerators, right? No problems. However, when the denominators were different, okay, different. By the word denominator, what do I mean? The bottom number. When the bottom number was different, I needed to come up with a common denominator. Okay, so I would change this one to 6, right? And if I doubled the 3, I'd also have to double the 1. So 2 over 6, 1 over 3 becomes 2 over 6. So when I add the numerators now, I can add numerators if the denominator is the same. I wind up with 4 over 6. Okay, so that's a quick refresher. We don't need this, but that was... Okay. Same rules apply for algebraic fractions. Common denominator, I can simply add the numerators. Now coming back to my monkey terminology, are these two letters or two animals the same animal? 1 ape plus 2 apes? How many apes? Okay, so that's how we'd write that one. And some of you might be able to see straight away that the 3's could cancel. And we could write that one as x. But for the explanation, I'm just going to leave it as a fraction. So similarly, if I did like, say, x squared over 5 minus, say, 3x squared over 5, because the denominators are the same, my new fraction has the same denominator, and I just need to do... Are these the same animals? Common denominator, we can carry this common denominator, it's 5, but are these common or similar animals? Same animals? They are? They're both double-headed baboons or apes, whatever you want to call them. So one of them minus 3 of them is minus 2 double-headed x's. Now, some people ask me, does it matter if I write it like this, or like this? Okay, the answer is that these are more conventional, but they all are the same thing. It doesn't matter where you put the minus, in other words. In front of the 2, in front of the fraction, or in front of the 5. These two are the more conventional ways, but this is equally correct. Okay, now I'm going to mix up the denominators, so the denominators aren't going to be the same. Here's my first example. The same one in the text. Okay, different denominators. I'm going to write two new fractions, but they're going to both have the same denominator. Rory's going to tell me what that same denominator is going to be. 15. Where did you get 15 from, Rory? 3 times 5. So I'll just write a little 3 times 5. That always works. There are sometimes other numbers you could choose, but when you multiply the two denominators, that will always work. So the new denominator is 3 times 5, 15. So this equation here, I multiplied the bottom by 5. To make it an equivalent fraction, what do I have to do? Times the top by 5 as well. Regan, could you tell me what I have to do to this fraction?
The denominator by 5.
By 3 this time. That's what this one was times by 5. This one was times by 3. Therefore, the top one has to be times by 3. Okay, so this fraction here and this fraction here are equivalent, and this fraction here and this fraction here are equivalent. They're exactly the same fraction, but the only difference being that they have common denominators. When I have common denominators, I can add them or add the numerators. 5x plus 3x is 8x, and there's my answer. Okay, let's step it up. Here we go. This one comes from question 3 on page 164. And it's x plus 1 over 2 plus x plus 3 over 5 rather. Different denominators, I can't just add the numerators. So I have to write two new equivalent fractions with equivalent denominators. What's the equivalent denominator going to be? 10, because 2 times 5. To this fraction, I ended up multiplying the denominator by 5, therefore I have to multiply the top by 5. To do that, I really need to use some brackets. Okay, because everything on the top has to be multiplied by 5, not just one term, both terms. So top and bottom by 5. To this fraction, Jono, what did I multiply this 5 by?
2.
So what should I do to the top?
Times by 2.
Correct. So on the top here, x plus 3 has to be multiplied by 2. Brilliant. I have a common denominator 10. I'm just going to slightly change where the 5 is now, put it in front, and put the 2 in front. I've shifted the 2 to there, I've shifted the 5 to there. I've written it as an equivalent fraction. Am I finished? What else can I do? Expand the brackets and simplify. So someone said 5x, keep going Wayne, plus 5 2x plus 6, well done, all over 10. Am I finished? What can I do last, Dylan? To get what? Correct. And the 5x plus the 2x, they are the same animal, so that's 7x. Correct. Well done. Any simpler? Can I do anything further? Can anyone simplify that any further? Don't say yes, because you'll embarrass yourself. That's as far as it goes. Okay. Let's do one more. Anyone want to pick a hard one?
4H.
4H. Whoa. I don't know if you're ready for it.
Whoa.
Let's do 4H. Oh. Okay, writing it out. X plus 1 over 4 plus 2x minus 1 over 3 Great. I'm going to write 3 equivalent fractions this time, not 2, 3. And they're all going to have the same denominator. What's that denominator?
12.
Oh yeah, 12 will work. I was thinking 4 times 3 times 2. But 12 goes into... 4 goes into 12, 3 goes into 12, and 2 goes into 12. So 12 will work. Keep the signs the same. Okay, what was done to the 4? It was multiplied by...
3.
So the denominator was multiplied by 3. What must be multiplied the top?
3.
Have to do the same to the top, right? Otherwise it doesn't become... It's not an equivalent fraction. There's no sign in there, so that means it's multiplication. What was done to the 3?
4.
The 3 was times by 4 to give 12. So therefore I should also times the top by 4. 2x minus 1. Everything has to be multiplied by 4. What was done to the 2? Was multiplied by 6. Therefore the top should be multiplied by 6. 3x plus 2 multiplied by 6. Right. One big new fraction now, all over 12. And I'm just going to shift things around slightly. I'm going to bring the 3 in front. And it's going to be read 3x plus 1 plus, I'm going to write 4 in front, 2x minus 1. I'm going to write the 6 in front, and I'm going to use the minus 6, 3x plus 2. Am I finished? No. I can do the expansion. The brackets. 3 times x. 3 times 1. 4 times 2x. 4 times minus 1. Minus 6, don't forget the minus, times 3. And minus 6 multiplied by positive 2. Negative 12. All over 12. I'm just going to circle things that are common or the animals are the same. What's 3 plus 8? Minus 18? Negative 7. Again, these things are the same. What's 3 minus 4? Minus 1. And minus 1 minus another 12. Okay, and it's all over 12. Look at that. Well done, Mr. Arden.